Hello folks, I welcome you all to ARC. Let's look into the subject operational research. In this video, we are going to see how to solve linear programming problems of maximization case using Simplex method. Here comes the problem. A firm producing two products A and B. A requires 2 kg raw material 4 laborers and B requires 3 kg raw material 3 laborers. But only 60 kg raw material and 96 laborers is available for a week. If 1 unit of A is sold, 40 rupees will be the profit. If 1 unit of B is sold, 35 rupees is the profit. Formulating this problem into linear programming, and then we need to determine how many units of each product to be produced per week to experience maximum profit. Here is the process of Simplex method. The first step is formulating objective function and constraints. The second step is standardization of the problem. Third goes like this: obtaining the initial tableau and solution. And the fourth one, testing the optimality of the solution. And fifth one is deriving a revised tableau for improvised solution. And sixth one is deriving a revised tableau for improvised solution. Let's begin the process with step number 1, formulating objective function and constraints. The products given in the problem are A and B. Raw material required for A is 2 kg, for B is 3 kg. And manpower required for A is 4 hours, for B is 3 hours. The profit per unit of A is 40 rupees and for B it's 35 rupees. And number of units produced, let it be for A x1, for B it's x2, and total individual raw material required for A will be 2 into x1, that is 2x1, and for B it will be 3 into x2, that is 3x2. Similarly, the manpower total will be 4 into x1, 4x1, 3 into x2, that is 3x2. Similarly, the profit will be 40 into x1, 40x1, 35 into x2, 35x2. Let's calculate the grand totals. The grand totals will be 2x1 plus 3x2 for raw material, 4x1 plus 3x2 for manpower, and 40x1 plus 35x2 for profit function. And now we have to include less than or equal to 60 as we need to cover the range of values from 0 to 60. Similarly, for manpower, we have to cover 0 to 96. Let it include less than or equal to 96. By doing this, we have formulated the objective function 40 into x1 plus 35x2, raw material constraint 2x1 plus 3x2 less than or equal to 60, manpower constraint 4x1 plus 3x2 less than or equal to 96. Step number 2 is standardization of the problem. Transforming inequalities into equations by introducing slack variables. Slack variables are variables which represent unused resources. And let's now take 2x1 plus 3x2 less than or equal to 60. Now this is an inequality. We have to transform it into an equation. Let's see how we do that. And the given total raw material availability is 60 kg per week. Let's allocate some of the raw material to product A and product B. And units allocated for product A is 12 and units allocated for product B, let it be 18. And apart from this, the unused raw material will be 30 units. Now you can see product A and product B, 12 units and 18 units is allocated for production, whereas 30 units is unused. 12 units are represented by 2x1, 18 units are represented by 3x2. But if you want to equate, or if you want to transform the inequality into an equation, we have to equate this 30 units or represents this 30 units in the equation by introducing some variable. Let it be S1. This S1 is called slack variable. If we introduce the slack variable, the equation will be like this: 2x1 plus 3x2 plus S1 is equal to 60. You can see the objective function and raw material manpower constraints. The standardized equations will be like this. Objective function will be 40x1 plus 35x2. Raw material constraint will be 2x1 plus 3x2 plus S1 is equal to 60. S1 represents the unused raw material, where manpower constraint will be 4x1 plus 3x2 plus S1 is equal to 96, where S2 represents the unused manpower. These are standardized equations, but to process the problem some more levels, we have to transform these standardized equations into the standard form, where standard form represents that every equation should consist all the variables that are there in the system of linear equations. So if we have to introduce all the variables like x1, x2, s1, s2 in all the objective function, raw material constraint and manpower constraint, the standard form will be like this. Objective function will be 40x1 plus 35x2, 0s1, 0s2. Raw material constraint will be 2x1 plus 3x2 plus s1 plus 0s2 is equal to 60. And manpower constraint will be 4x1 plus 3x2. Understand the standard form of the objective function. 40x1. 40 is the profit per unit of A and x1 represents the total number of units of A being produced. 40 into x1 gives us the total profit that we can make by total number of units of A. Similarly, 35 into x2. 35 represents the profit per unit of B and x2 represents the total number of units of B being produced. The product of the both gives rise to the total profit that we can make by producing B products. Similarly, 0 is the profit per unit of unused raw material. Since we don't use any raw material, we can't make any profit. So the profit that we allocated for S1, the unused raw material, is 0. S1 represents the total number of unused raw material and the product of both equals to total profit by unused raw material, which will be 0. 0 is 2. 0 represents profit per unit of unused manpower. Since we are using no manpower, so what the profit we get is 0. We get nothing from something we unused. So 0 represents the profit that we are getting no profit, and S2 represents number of units of manpower which are being unused. The product of the both gives rise to total profit that we get by the unused manpower, which is 0. So we have standardized the objective function, raw material constraint, manpower constraint, and written in the standard form. Now we can proceed to the next step. Let's start the third step, obtaining the initial tableau and solution. Now we will make a tableau using this standard forms of equations. Now consider all the variables that are there in the objective function and constraints. x1, x2, s1, s2. Bj represents the constants of the equations. Now we will enter the coefficients of raw material constraint. 2, 3, 1, 0 and 60 is the constant. Now let's enter the manpower constraints. 4, 3, 0, 1, 96. Then we will introduce basis variables. Basis variables are the variables that we introduce every time we construct a new tableau. For the first tableau, we will take the basis variables S1, S2 with their coefficients in the objective function. For S1 and S2, the coefficients in the objective function is 0, 0, which represents that there is no profit by unused resources. You can see that for S1, the Bj is 60 and for S2, Bj is 96. That means the slack variable of raw material consists 60 kg. That means no raw material is allocated for production, and for S2 it contains 96 manpower, 96 hours of manpower. That means no manpower is allocated for production, completely is unused, represented by S2. Cj is the objective function, 40, 35, 0 and 0 for S2. As we see the objective function, the coefficients are like that. Cj values represents the contribution per unit. A contributes 40 rupees, B contributes 35 rupees. Now next step is calculating Zj values. Let's calculate Zj. Zj can be derived by multiplying the coefficients of basis variables with the coefficients of all the variables and adding the result. Let's see how it works. 0 into 2 plus 0 into 4 gives us 0. Similarly, 0 into 3 plus 0 into 3 gives us 0, and 0 into 1 plus 0 into 0 gives 0, and 0 into 0 plus 0 into 1 gives 0. These values represents the loss that we need to incur when one product is added to the mix. What does it mean? For this, we need to understand from using the basic solution. You can see here the basic solution is x1 is equal to 0 and x2 is equal to 0, s1 is equal to 60 kg and s2 is equal to 96. We know that s1 and s2 are the slack variables which represents the unused raw materials. This basic solution saying that we are not allocating any of the resources to produce any of the units of A or B. That means we are completely unusing the raw materials. From this, if we want to produce any of the unit like for A or B, we have to take some raw material and manpower from the slack. So that since the cost of S1 and S2 are 0, 0, so we need not to take any cost, so that the J values are zeros for all the variables. Now let's calculate delta J. Delta J can be calculated by subtracting ZJ value from CJ values. Let's see that. 40 minus 0 gives us 40. 35 minus 0 gives us 35. 0 minus 0 gives us 0, and 0 minus 0 gives us 0. Now, this is net profit. That means whenever we produce one unit, we will get 40 rupees as net profit. X2 1 unit, we will get 35 rupees as net profit. This is nothing but the net contribution of each product when manufactured and sold. The fourth step is testing the optimality of the obtained basic feasible solution. Now we have calculated delta J values for the previous problem, and when the delta J values are greater than or equal to 0, which means all the values of delta J obtained in the problem either 0 or positive values, then that case is maximization case. Let's see what is the condition for minimization case. When the delta J values less than or equal to 0, which means all the values of delta J either 0 or negative values, then the case is minimization case. How can we conclude that we have arrived the solution? So here is the condition. Once we attain all the values of delta J either 0 or negative values, we can stop the iteration or we can stop the process of solving, believing that we have obtained the optimal solution. Similarly, when we obtain all the values of delta J either 0 or positive values, we can stop the iteration believing that we have obtained optimal solution in the minimization case. The upper one was for maximization and this for minimization case. This is the testing conditions for optimality of the solution. If we see now, the delta J values we have calculated in the table 1 are all positive values and zeros. Hence, we can conclude this case belongs to the maximization case. So, how can we attain the solution? Now we have to revise the table by improving the solution until we get zeros or negative values for delta J. And this can be done by introducing the variables whose contribution is more. Let's identify that. Now the fifth step is deriving a revised tableau for improved solution. What we have to do is we have to identify a variable which is contributing more to the profit, and we have to introduce that variable into the basis variables. Now if you see here, X1 product is contributing 40 rupees, which is maximum, and let this column be key column. And what we have to do is we have to divide the values of BJ, which are 60 kg raw material and 96 labor hours, which are the resources we have, by the coefficients of X1, which means 2 kg and 4 labor hours. So we have to divide those coefficients with 2 and 4.
Let's see what we get. 60 divided by 2 gives 30 and 96 divided by 4 gives 24, which represents the maximum number of products that we can make out of 60 kg raw material and 96 labor hours. That means using 60 kg raw material, we can produce 30 products of X1, and using 96 hours, we can produce 24 products of X1. But due to limited manpower, we can only produce 24 products per week. So let's select 24 row as key row. Now the element which is common in the both key column and key row, let's take it as key element. Now we have to do process using this key element in further steps. Now we have taken the key row, and let's understand these elements, what they are representing in reality. 4 represents to produce 1 unit of X1, we need to give away 4 hours of manpower from slack S2. 3 represents to produce 1 unit of X2, we need to give away 3 hours of manpower from slack S2. 0 represents there is no slack of raw material in S2. 1 represents if 1 hour is increased in manpower, then S1 increases by 1. 96 represents the total unused manpower in the slack, that is 96 hours, which is stored in S2. So we have understood that the elements of S2 are hours required for production of each product. Now, to transform these elements into elements of X1 so that we can introduce X1 variable whose contribution is more into the basis variables, we have to divide all the elements by 4. And this means that we are allocating all the manpower to produce only X1. Now let's divide by 4. If we divide by 4, 4 by 4 gives 1, 3 by 4 gives 3 by 4, 0 by 4 0, 1 by 4 gives 1 by 4, and 96 by 4 gives 24. Now let's understand what these values of X1 represents in reality. 1 represents if we produce 1 unit of X1, the number of units of X1 increases by 1. That's why X1 and X1 having commonly 1. 3 by 4 represents to produce 1 unit of X2, we need to give away 3 by 4th hour of manpower, which is required for producing 1 unit of X1. 0 represents since we can't increase S1 by giving away any manpower, so it is 0. 1 by 4 represents to increase S2 1 unit, we need to give away 1/4 of X1 unit. 24 represents the total number of products that we made by allocating 96 hours, which we have the complete manpower for producing only X1. Out of 96 hours of manpower, we can produce 24 units of X1. Now we have allocated 96 hours of manpower for production of X1 and realized that at max we can produce 24 products of X1. Then to produce 24 products, not only using the manpower, we should also use raw material. What we have to do is we have to allocate the raw material for 24 products now. For this, we need to remove the raw material which is there in the slack, and then we have to allocate for that to the production of X1. Now we take away the raw material required for the 24 products of X1. We can do this by multiplying all values of X1 with 2, then to remove the required raw material for 24 products of X1, we subtract these values from S1 values. We have to multiply the elements of X1 with 2. Why with only 2? 2 is the amount of raw material which is required for production of 1 unit of X1. If we multiply all these elements with 2, we will get how much amount of raw material that we have to required for production of 24 units. Now see, we'll multiply 2 into 1, 2, 3 by 4 into 2, 3 by 2, 0 into 2, 0, 1 by 4 into 2, 1 by 2, 24 into 2, 48. This 48 represents that we need to have 48 kg of raw material to produce 24 units of X1. So what we have to do is we have to take this 48 out of the 60 kg available in the slack. Now let's subtract the derived elements from elements of S1. 2 minus 2 gives us 0. 3 minus 3 by 2 gives us 3 by 2. 1 minus 0 gives us 1. 0 minus 1 by 2 gives us minus 1 by 2. And 60 minus 48 gives us 12. In this step, our aim was we have to derive a revised tableau. That means a tableau with new elements, revised elements. So you can see these are the revised elements. Let's understand what does the elements in S1 represents. 0 represents since we have produced a maximum of 24 units of X1, no more raw material allocates for production of X1. And 3 by 2 represents to produce 1 unit of X1, we need to give away 3 by 2 kg of S1, which is in the slack. And 1 represents if we increase 1 kg in the slack S1, the S1 value gets increased by 1. The minus 1 by 2 represents that if we give away 1 unit of manpower, that is 1 hour in S2, then the slack of S1, which is raw material, gets added 1 by 2 kg. That means half kg. How this happens? For example, if we take the case of X1 product, if we have to produce one product of X1, it requires 4 hours of manpower which process 2 kg of raw material. If we take for every 1 hour, we are utilizing half kg of raw material. That means if we have to reduce the manpower for 1 hour and then we need to give away half kg of raw material, that unused raw material will be added back to the slack. This 12 represents that after producing 24 products in the slack, if we give away 48 out of 60, the slack will be consisting 12 kg of raw material unused. So here are the new rows of revised tableau, and let's introduce those values into the table. Now the coefficient of x1 is 40 rupees in the contribution function, and let's calculate the values of ZJ elements. 0 into 0 plus 40 into 1 gives 40. 0 into 3 by 2 plus 40 into 3 by 4 gives 30. 0 into 1 plus 40 into 0 gives 0. And 0 into minus 1 by 2 plus 40 into 1 by 4 gives 10. Now, the basic feasible solution will be like this. X1 is equal to 24 products. That means we have produced 24 products. And X2 is equal to 0. That means we have not produced any product of X2. And S1, the slack of raw material, still have 12 kgs. And S2 is equal to 0. That means 96 labor hours are completely used for producing X1. So this is the basic feasible solution. How can we derive this basic feasible solution? You can see here the basic variables are S1 and X1, and the BJ values are 12 and 24. We have to include these two values into the basic feasible solution, and the other variables which are not there in the basis variables, we have to allocate zeros. That means all the resources are there allocated for only these basic variables. Now as the process, let's calculate delta J. 40 minus 40 is 0. 35 minus 30 gives 5. 0 minus 0 gives 0. And 0 minus 10 gives minus 10. Now, as we see, delta J values consist 0, positive and negative values. So, We have to revise the solution further so that we can get zero and negative values. This can be done by introducing the variables whose contribution is more. Now the iterative process continues. You can see here 5 is the maximum profit. Let this be key column. The x2 is the key column, and what we have to do is we have to divide the bj values 12 and 24 with the coefficients of x2, and let's see what we get. 12 divided by 3 by 2 gives us 8, and 24 divided by 3 by 4 gives us 32. This 8 and 32 represents number of products that we can make if we allocate these raw material and manpower completely for only x2. And because of the limited raw material, we can only produce 8 products per week, and let this be key row. And if you see, the element which is common for both the key column and key row is 3 by 2. Let it be key element. Now we are going to process this table for a better and improved solution using the key element 3 by 2. Now we need to divide the elements of S1 with 3 by 2. If we divide the 3 by 2, the elements of S1, which represents the kgs of raw material required for production of each product, will be transformed to the elements of X2, so that we divide all the elements by 3 by 2, which means we are allocating all the raw material to produce only X2. If we divide S1 values with 3 by 2, 0 gives us 0, 3 by 2 gives 1, and 1 by 3 by 2 gives 2 by 3, minus 1 by 2 gives us minus 1 by 3, 12 gives us 8. These are the values of x2. These are processed. Now 0 represents that since we produced a max of 24 units of x1, we can't produce any products with no power because no manpower is available now, completely used by x1 production. 1 represents if we produce 1 unit of x2, its number increases by 1. 2 by 3 represents to increase slack S1 1 unit, we have to give away X2 2 by 3 unit, that means 2 by 3 kg. Minus 1 by 3 represents increasing slack S2 by 1 hour, X2 1/3 unit of raw material which is required for production of one X2 product, that is 1 kg raw material, is given away. That means X2 one product requires 3 kg of raw material which is processed for 3 hours. That means 1 kg of raw material needs 1 hour of processing. If we given away or if we unuse 1 hour of manpower, then automatically this leads to giving away of 1 kg raw material, that is represented in the form of minus 1 by 3. 8 represents when we allocate 12 kg raw material to produce X2, we can produce at max 8 units. Using 12 kg of raw material, we produced 8 products of X2, but we allocated all 96 hours for X1 production only. To produce 8 products of X2, we also should allocate manpower as well. For this, we need to remove manpower of X1 required for 8 products of X2, which reduces the products of X1. Now, to allocate the manpower which is required for 8 products of X2, we multiply all the values of X2 with 3 by 4 and then subtract those values from values of X1 so that we can take away the manpower required for 8 products of X2 from X1. Why we have to multiply only with 3 by 4? We know that for production of X2 1 unit, we requires 3 hours of manpower, and for production of X1 1 unit, we require 4 hours of manpower. 3 is nothing but 3 by 4th time of 4 hours. If we multiply 8 with 3 by 4, we will get total amount of time or manpower required for production of 8 units. Then we can subtract that from x1 values. Now let's see what values we will get if we multiply the elements of x2 with 3 by 4. 0 into 3 by 4 gives us 0. 1 into 3 by 4 gives us 3 by 4. 2 by 3 into 3 by 4 gives us 1 by 2. Minus 1 by 3 into 3 by 4 gives us minus 1 by 4. 8 into 3 by 4 gives us 6. Take your own time and calculate those values. Don't get confused. Now let's subtract these values from x1 values. 1 minus 0 gives us 1. 3 by 4 minus 3 by 4 gives us 0. 0 minus 1 by 2 gives us minus 1 by 2. 1 by 4 minus of 1 by 4 gives us 1 by 2. 6 is subtracted from 24 gives us 18. These are the new rows of revised tableau. Let's understand each element of x1. 1 represents if we produce 1 unit of x1, its number gets increased by 1. 0 represents if we produce x1 18 units, we won't allocate any raw material for further production of x2. That's why we represented 0. Minus 1 by 2 represents if the slack S1 has to be increased by 1 unit, then we need to give away half unit of x1. How is this possible? That means x1 requires 2 kg of raw material. 2 kg of raw material, if we want to give away or if we want to unuse 1 kg of raw material, that means which leads to increase of slack S1 by 1 unit, automatically we have to reduce the unit of x1 by half. So that is minus 1 by 2. 1 by 2 represents to increase 1 unit of S2, we need to give away x1 1 half unit. 18 represents after taking away manpower required for 8 units of x2, we are left with only 18 units or 18 products of x1. Let's calculate ZJ values. ZJ values 35 into 0 plus 40 into 1 gives 40. 35 into 1 plus 40 into 0 gives us 35. 35 into 2 by 3 plus 40 into minus 1 by 2 gives us minus 10 by 3. And 35 into minus 1 by 3 plus 40 into 1 by 2 gives us 25 by 3. Now the basic feasible solution is like this. X1 is equal to 18 products, X2 is equal to 8 products, and there is no slack unused. That means we have produced 18 products of X1 and 8 products of X2 without having any unused resource. Now let's calculate delta J. 40 minus 40 gives us 0. 35 minus 35 gives us 0. 0 minus 10 by 3 gives us minus 10 by 3. And 0 minus 25 by 3 gives us minus 25 by 3. As we see, delta J values all are zeros and negative values. So now we can stop the iteration as per the conditions of optimality testing. Now the optimal solution that we have derived is producing x1 18 products and production of x2 8 products. This says that if we produce A 18 number of units and B 8 number of units, we can attain maximum profit, that is 18 into 40 plus 8 into 35, which is 1000 rupees. Like, share and subscribe. Please support me. Signing off, your Prem Kumar.